Hello, my name is Dave Strain. I'm president of APS. APS is a systems development company dedicated to identifying practical solutions to climate change and helping create a brighter future for today's children. Over the years, we've developed advanced HVAC control logic that has reduced energy consumption in some buildings by more than 50%, often by applying straightforward common sense principles to system operations. We've also developed an internationally patented climate change solution that challenges aspects of conventional scientific understanding and has undergone patent examination in multiple jurisdictions where we were receiving patents. Our website, apscontrols.org, contains articles, case studies, videos, patents, and a 355-page energy conservation training manual that focuses on reducing consumption and greenhouse gas emissions. To encourage open evaluation and discussion, we placed our patents in the public domain. There is no donate button on our website, and as stated on its cover, the training manual is available free of charge. We are not asking for your money, but we do need your voice. By encouraging open evaluation of these proven energy savings technologies and conservation strategies, you can help move practical climate change solutions from the drawing board and prototypes into real-world applications for the benefit of future generations and the current children living today. This slide illustrates a conventional piston on the left and the more efficient diamond-shaped actuator, DSA, on the right. The DSA was evaluated and peer-reviewed by multiple engineer scientists and also passed by multiple international patent examiners to grant patents. The testing of the physical models indicated an efficiency advantage ranging from 15 to 17%, favoring the DSA. Mathematical analysis conducted by an aerospace scientist from the University of Toronto concluded that in a frictionless model, the theoretical maximum advantage could be as high as 26%. Engineer scientists from Cenis Consultants conducted testing both at my facility and at their laboratory and confirmed my claims obtained through their testing of the physical models. This video is divided into 4 brief presentations. This is a presentation of the patents granted in Canada, the United States, and Europe. We also had the approval of the PCT examiners, who are the Patent Cooperation Treaty individuals, and they represent the globe. And it demonstrates also in this video the operation of both the conventional piston and the DSA. The patents were granted through the US, Canada, and Europe. The basic principle of this invention is a more efficient hydraulic actuator. In this case, it's a pneumatic actuator. It's the same thing as the fluid and the hydraulics. The pressurized fluid goes into the actuator on one side. There's what they call a boundary face there. It's the square inches of moving face that is connected to the shaft. So what happens if you have a pressure of 10 pounds per square inch into the actuator and a face area of 10 square inches, consequently you would have 10 times 10 would be 100 pounds of force on the shaft. So when I open up this valve, exposing this actuator to pressure on this side, you see what's happening is the shaft's coming out, and so it is actually driving with 100 pounds of force based on that. The first model of the new type invention, it's a diamond-shaped actuator. So I'm going to pressurize it there, and you'll watch the action of a diamond-shaped actuator. And what you see happen here is the diamond is expanding based on the pressurized fluid within the diaphragm there. It's driving forward. So what happens in this respect is that the pressure on each of the 4 faces comes together as a total force, which is on the shaft here. The benefit generating the advantage over a conventional piston is that if each of the walls here is equal to the area of what would be in the conventional piston, then what happens is for any linear movement in this direction, there'd be less of a volume change within this actuator than when there would be in a conventional piston. And then the other benefit is that the total force at the tip of this exceeds the force that would be experienced with a conventional piston with the exact same fluid change. This presentation presents 2 different formulas to explain how the diamond-shaped actuator can generate its own source of fluid by forcing it out of a conventional piston. An efficiency advantage of at least 70% has been shown in favor of the diamond-shaped actuator, the DSA, over a conventional cylindrical piston, as confirmed by multiple scientists. Consider a DSA positioned opposite a conventional piston, as illustrated in this drawing. Both chambers pressurized to 10 psig. Under these conditions, the DSA produces 117 pounds of force, while the conventional piston produces 100 pounds of force. As a result, the DSA overpowers the piston, forcing fluid from the piston's chamber into the DSA's chamber, while still retaining surplus displacement capacity, representing additional work potential. To quantify this effect, we can apply the familiar relationship work equals pressure times volume change. For the piston, 10 psig times 10 cubic inches equals 100 inch-pounds of work. For the DSA, 10 psig times 9.9 cubic inches equals 99.9 inch-pounds of work. In this analysis, the input work corresponds to DSA's volume, while the output work corresponds to the piston's volume. The calculated work output exceeds the calculated work input. When the alternative work relationship is applied, work equals force times displacement. The measured force differential indicates even greater surplus work potential. Based on the documented 70% efficiency advantage, less than one-third of this gain is required to operate the patented reciprocating machine itself, leaving at least 11% available for external energy production. This presentation provides the proof that of the 17% efficiency advantage that the diamond-shaped actuator has over a conventional piston, it only requires 5% of that differential advantage in order to produce its own fluid source. Consequently, the diamond-shaped actuator has a remaining minimum of 12% surplus work potential to achieve its ends in running the machine. This apparatus is designed to determine the counter force required on a piston shaft to expel fluid from that piston. Based on peer-reviewed testing and analytical calculations, the diamond-shaped actuator, the DSA, demonstrates an achievable efficiency advantage of approximately 15 to 26% over a conventional cylindrical piston. The magnitude of this advantage is nonlinear due to differing geometries of the two devices. In practical terms, when both actuators are supplied with the same fluid volume at the same pressure, the DSA is capable of producing at least 15% more useful work output than a conventional piston. The critical question, therefore, is how much of this efficiency advantage is required to overcome the resistance of a secondary piston. More specifically, what force differential is needed to expel fluid from another piston, thereby establishing an independent fluid source while still retaining surplus work capacity. To evaluate this condition, the pressure applied to the right-hand piston is reduced by 4.4 psi. This creates a pressure differential equivalent of approximately 6% of the available 70 psi supply pressure. Consequently, if the left-hand piston shown in red is replaced by a diamond-shaped actuator, the DSA's minimum 15% efficiency advantage would exceed the 6% force differential required to overpower the secondary piston. This would leave more than 9% net surplus work potential available after the DSA supplied its own fluid source. This demonstration is to illustrate the fluid being pushed out of an actuator with the counterforce on its shaft. Now we have 70 psi to both the actuators in this demonstration. They're both conventional pistons. The left-hand one we got to maintain at 70 psi, and on the right-hand one we're going to drop the pressure in there by 4.4 pounds. See, you hear the controls winding a bit now, and you see the upper gauge goes up to the 4.45 pounds. Now watch the bottom two gauges. What you see is the left hand of the bottom two gauges will jump up, which you just saw. And actually, if you look at the linkage, you see it, in fact, is actually moving to the right toward the second actuator. So the second actuator currently is having fluid pumped out of it by the left-hand actuator. Now, that a percentage difference of 15% for a diamond-shaped actuator would mean that it would have available to an at least 10 pounds pressure differential to make our science be proven. We're all going to use 4.4 of that 10 to demonstrate this. So we'll have 6 pounds surplus work left over were a diamond-shaped actuator riding on the left-hand piston doing the work. So we would be able to run the operation of our reciprocating machine, and also there would be surplus power left over to generate clean energy. Now you see the linkage is approaching the second push button, and in a minute you'll see that second push button jump up to, it's almost there, and it's about to jump up on the second gauge, there it goes. So you've seen a differential of 4.3 to 4.4 pounds on that gauge cycling. And you see that amount that was capable of causing the right-hand actuator to have fluid pumped to the right. On our website, apscontrols.org, there's an article titled Fighting Climate Worry. Within that article are links to two reports that are highly significant when considering the future of today's children. The first is a BBC report indicating that more than 50% of children are regularly worried about climate change. The second is a Stanford University report projecting that the world could exhaust its economically recoverable fossil fuel resources within the lifetime of children living today. These findings underscore the importance of taking climate change challenges very seriously and pursuing practical, effective solutions. Just as importantly, we need to demonstrate that meaningful action is being taken, helping to reduce the anxiety many young people feel about their futures. Those who dismiss this claim as impossible may wish to consider the basis on which they reject the invention. If their position is founded on scientific reasoning, several questions deserve consideration. Number one, what did the patent examiners in multiple countries overlook when they reviewed the evidence and granted patents on the invention? Number two, what did the peer review scientists overlook when they concluded that the efficiency differential was at least 15%? Number three, what did the aerospace engineering professor from University of Toronto overlook when he calculated that the maximum efficiency differential could reach 26%? Science advances through careful examination of empirical evidence. New discoveries are not validated by age of existing opinions, but by their ability to withstand observation, testing, measurement, and critical review. Thank you very much for your efforts with respect to addressing climate change. I believe that collectively, with everybody trying, we can make a major impact on the threat to the children's future.